Dear grade 8 chemistry students, Assalamu alaikum jami'an wa rahmatullahi wa barakatuh. In this project, we are going to solve the typical exercise of the molecules lessons. So let us train our brains to increase the skills. Come in, guys. Our objectives here are to define molecules and give examples, calculate the number of atoms in a given number of molecules by solving these typical exercise. Materials required are chemistry copybook, the chemistry worksheet, and the pen, please. So this project will take 15 minutes. Let us begin. First exercise, they ask us to define molecule. This is the definition that we have memorized. A molecule is a neutral group of atoms that act as an unit. What else? Classify the following in the table below into molecules or free atoms. So here we have several figures and we want to classify them into molecules and free atoms. Firstly, we should read carefully the legend. Here we have this symbol represents the oxygen atom as you see in figure 1, while the gray ball represents the carbon atom, the white small ball represents hydrogen atoms as here, while this ball represents the iron atom. So let us begin. Molecule. What about figure 1? What do we have in figure 1? We have these balls represents oxygen atoms. How many oxygen atoms do I have here? I have 2. So the molecule, which is more than one atom, is applied on figure 1, which has 2 oxygen atoms. So figure 1 is considered as molecule. What about figure 2? How many atoms? 1, 2, 3, 4, 5. We count the atoms. So we have 5 atoms. Is this a molecule? Yes. Figure 3. How many atoms? 1. So it is a free atom. So figure 3 we put here in the column of free atom. What about carbon dioxide? CO2. How many atoms do we have? 1 C and 2 O. This means 3 atoms. So it is considered as a molecule. Cu, which is a symbol of copper, it represents 1 atom. So it is a free atom. H2O, the water, made up of 2 hydrogen atoms and 1 oxygen. So 3 atoms, molecule, and the same things for O3, 3 oxygen atoms. So it is a molecule. Is it clear? Let us continue. Classify the molecules, which are classified in the row of molecules, in 2 groups, diatomic molecule and polyatomic molecules, and justify. So here we have the group of the molecules, and we want to classify them into diatomic and polyatomic. Remember, guys, what is the meaning of diatomic? Di means 2. While poly means many or several. So let us speak about figure 1. Figure 1 is a molecule made up of how many atoms? 2. So is it diatomic or polyatomic? It is diatomic molecule. What about figure 2, which made up of 5 atoms, so more than 2, then it is considered as polyatomic. Same thing repeated for the other. CO2 made up of 3 atoms, so it is polyatomic. H2O, 3 atoms, also polyatomic. And finally, we finish by O3. This is made up of more than 2 atoms, so it is polyatomic. Don't forget that diatomic molecules are molecules made up of just 2 atoms or 2 atoms only, while polyatomic molecules are molecules that made up of more than 2 atoms. Keep in mind. Let us move to second exercise, guys. Consider the following molecule, CH3, CH2, COOH. Justify why this substance is considered to be a molecule. Think, guys, why? What is the definition of molecule? We have said that the definition of molecule is a neutral group of atoms. The group of atoms. Look here, how many atoms do I have? Are they one, two? It is a group that act as a unit. Look at this formula. It is acting as an unit. So with that, we say in the answer that it is a molecule since it is formed of a group of atoms that act as an unit. Number two, give the molecular formula of this molecule. Remember how to make a formula, how to get the molecular formula of a molecule. We're starting by putting the symbol of each atom in capital form. Then we write at the lower right part the subscript. Do you remember, guys? Let us see. So we start by carbon. We write capital C. How many carbon atoms do I have? 3. So I put as a subscript 3. Now, other atom, the hydrogen. The hydrogen has symbol H. We write capital H. We count the hydrogen atoms. How many hydrogen atoms do I have? Here 3 and here 2. So they become 5. And in addition to this H, they become 6. So I have 6 hydrogen. This is the subscript of hydrogen. What do we have else? We have oxygen. So we write a symbol O here. We count the oxygen atoms in the molecule. We have 2. So the subscript of oxygen is 2. Is it clear now with the format? So the molecular formula now is C3H6O2. Number 3, indicate the number of carbon atom in this molecule. How many carbon atoms do we have in this molecule? It is so easy, guys. We look just on the subscript, which is 3, which represents the number of carbon atoms. So we have 3 carbon atoms. Finally, calculate the number. Keep attention here for this question because it is so important and it comes in many quizzes and exam and tests. Calculate the number of oxygen atom, just oxygen atoms, in 4 molecules of this compound. So if I take this compound, if I have 4 molecules of this compound, how many oxygen atoms do I have in them? We say that if I want to count the oxygen atom in one molecule, how many oxygen atoms do I have? We have 2, which is a subscript of oxygen. So we say that in one molecule we have of this compound, there are 2 oxygen atoms. So in 4 molecules of this compound, how many oxygen do I have? Just a calculation. We multiply the 2 oxygen by the number of molecules, which is 4. So 2 multiplied by 4, the answer is 8 oxygen atoms. Have you understood how? Third exercise, the adjacent histogram, other name bar graph, shows the number of atoms of each element present in cocaine molecule. So as you see, here we have the bar graph or the histogram that shows the number of atoms of each element in cocaine molecule. What do we have here? Transform the histogram into a table. Oh, so easy. This skill should be accepted in our mind to solve in chemistry and biology questions that are similar to this question. So how can I represent or transform the histogram into a table? Firstly, we draw the table. The first row in the table, what does it represent? The x-axis or the y-axis? No, surely the x-axis. So we take elements and put it here. The second row in the table represents the y-axis. What do we have on y-axis? So we write number of atoms per molecule. Here we put the symbols of the elements. We have carbon. How many carbon do we have? We read the number 15, 16, 17. So it is 17 carbon. H has 21 atoms. Here we have the oxygen, which has 4. Nitrogen finally has 1. What is the missing step here? The missing step here is to write a title. Don't forget, guys, because you will lose a part of your grade. So we write title, the number of atoms of each element per molecule. Is it clear? Now, moving into part 2. Give the molecular formula of cocaine. So easy. We start by writing the symbol. So we ask ourselves, what are the components of what cocaine contains? Atoms. What atoms we have in cocaine? We start by C. What is the subscript of C? How many C do we have? 17. So 17 is the subscript of carbon. What about hydrogen? We write H. Subscript of hydrogen is 21. O, 4. And finally we have nitrogen. The subscript of nitrogen is 1. Remember, guys, do we put subscript 1 or there is no need to put the subscript when we have one atom? So we cancel the 1. So here is the molecular formula of cocaine. Now determine the number of carbon atoms found in 4 cocaine molecules. How many carbon atoms do we have in 4 cocaine molecules? So we say, as I have told you, don't forget, we start mentioning that in one molecule of cocaine compound, we have 17, or there is 17 carbon atoms. So in one molecule of cocaine compound, there are 17 carbon atoms. Then we say, so in 4 molecules of cocaine, or in 4 cocaine molecules, there are how much? We multiply the 17 by the number of the molecules, which is 4. 17 by 4, 68 carbon atoms. Is it clear? Now, part B, the following figure represents the molecular model, not formula. It is a model. So it is as a drawing of the morphine molecule. Here you have the molecular model of morphine. The most important is to understand the legend. Black balls represent carbon, gray represent oxygen, the big white ball represents nitrogen, while the small white ball represents hydrogen. Now write the molecular formula of morphine. How can I write it? We start by the first. We take the first letter in the alphabetic order. C is before O and N and H in the alphabetic order. So we start by carbon. We write the symbol of carbon is capital C. What about the subscript of carbon? I should count the carbon, which are the black balls, to get their number. So to get the subscript, we have 17 black balls. So I have 17 carbon. So this is the subscript of carbon. What else? The second letter is H, of hydrogen. So hydrogen, I should count the small white balls to get the number of hydrogen atoms. They are 19, so the subscript of H is 19. Same thing for nitrogen. How many nitrogen do I have? Just 1. Do I need to put the subscript? No, without subscript. What about oxygen? We are finishing by oxygen. How many gray balls do I have? 3. So the subscript of O is 3. So this is the molecular formula of morphine. Finally, for the next time, study the worksheet 6 plus typical exercise from page 13 to 16 for a quiz. Thank you for watching this video. تقبل الله أعمالكم. السلام عليكم جميعا ورحمة الله وبركاته.